This is the Chapter 1 mid-chapter quiz review. And it goes over sections 1-1 through 1-4. In section 1-1, we talked about writing algebraic expressions for verbal expressions and writing verbal expressions for algebraic expressions. And so in number 1, they're asking us to write the verbal expression for the algebraic one. And remember, when we go from math to English, there's a bunch of different ways that we can go. One way that we could say is that this is the difference, because it's subtraction, of 21 and x cubed. So we could also say that it was 21 decreased by x cubed, or x cubed less than 21. All of those would mean the same thing. We're working on not just reading it straight off, though, and saying 21 minus x cubed. Although that is correct, we're working on expanding our math and verbal vocabulary. In number 2, we're doing the same thing, and it's a little bit tricky. So what I would start with is this part here, plus 9, and I would say that it is 9 more than, and then this part over here, 3m to the 5th, I'm going to say is the product, because they're being multiplied, the product of 3 and m, and I'm going to reverse that, the 5th power of m. And then I'll explain why. I was initially going to write 3 and m to the 5th, but that gets a little bit vague, and when they translate it back to math, they might think that I mean 3m all to the 5th. So it's better to say that it's the 5th power of m, because then you can't assume this. In numbers 3 and 4, we're going the other direction, and we're writing the math expressions for the verbal ones given. So we have 5 more than s squared. Whenever I see 5 more or 5 less than, I always put that at the end. So 5 more means that we're adding 5 onto whatever we have. And they've said what we have is s squared. In number 4, it says 4 times y to the 4th power. So 4 times y, I put them right next to each other because it's a variable and a number. I don't need to put the times symbol in. And then y to the 4th power. Now again, this is what I was talking about. Do they mean 4y to the 4th, or do they mean 4 times y all to the 4th? But since it says 4 times y to the 4th power, I'm going to assume that they mean this way. Car rental. The XYZ car rental agency charges a flat rate of $29 per day, plus 32 cents per mile. Write an algebraic expression for the rental cost of a car for X days that is driven Y miles. So every day they're going to add on $29. So for 2 days it would be 58, and then for 3 I'd have 3 times 29, So what I'm basically doing is multiplying 29 by the number of days, and they say we go x days. So 29 times the number of days x, and then on top of that they're going to add the number of miles times y. So it says write an algebraic expression. This is the expression. They don't give us any more information, and they don't ask us to evaluate. So this is all I do. All right. The next thing that we do is evaluate expressions, which is what we learned about in section 1-2. And we learned about order of operations in that section. And it goes by please, excuse, my dear, Aunt Sally. Parentheses, exponents, multiplication, division, addition, and subtraction. So we'll use that as a tool as we solve these. So in the first one, we don't have any parentheses, we don't have exponents, and the first thing that we run into is multiplication and division. And just because we say multiplication first, remember, does not mean it goes first. We work left to right on multiplication and division at the first. Whichever we first run into comes first. So the first one I run into is 24 divided by 3, and that's 8. And then I still haven't dealt with 2 times 3. So then I continue on with multiplication and division, and the next one I run into is 2 times 3, which is 6. And I haven't done the minus yet. Now that I don't have any multiplication or division left, I do the next step, which is addition and subtraction. So 8 minus 6 is 2. In the next one, I look and I have no parentheses, but I do have an exponent, so that's what I'm going to do first. 2 squared is 4. And I don't have multiplication or division. The next step then is addition and subtraction, so 5 plus 4 is 9. Number 8, we have parentheses, and whatever's in the parentheses needs to be done first. So I'm going to do the 3 plus 9 first, which is 12. And since that's the only thing that was in the parentheses and now it's a number, I can write it without parentheses. And since the 4 was right next to the parentheses, it means multiply. So it's been simplified down to 4 times 12. I don't have exponents, so I do the multiplication and division next. 4 times 12 is 48. In number 9, again, I have parentheses, so I'm going to do those first. 1 plus 3 is 4. Anything that I haven't dealt with yet stays the same. And once I just have a number replacing what's in the parentheses, I can get rid of the parentheses. And that since the 2 was next to the parentheses, it's being multiplied. And since the squared was outside, it means whatever number the stuff inside turned out to be is getting squared. So I put the squared on the 4. Now that I'm done with parentheses, I move on to exponents. And I have an exponent. I have 4 squared, which is 16. Everything else stays the same because I haven't done anything with it. And then I move on to multiplication and division. And the first instance of that I run into left to right is 2 times 16, which is 32. And I don't have any more multiplication or division, so I move on to addition and subtraction. So 36 minus 32 is 4. And the last one, what I typically do is I treat the top and the bottom separately. So I kind of pretend like they're in parentheses. So on the top inside the parentheses, the first thing that I'm going to do is the exponent of 2 to the third, which is 8. And on the bottom, the next thing is inside the parentheses, I have 2 squared. So I'll do that first, which is 4. Everything else stays the same. Because I haven't dealt with it. And then on top, I don't have any multiplication or division, so I would move on to addition and subtraction. So on top, I would have 40 minus 8 is 32. On bottom, though, I do have multiplication left. So the first one that I run into is 3 times 4, which is 12. And then the last step for the bottom is the addition and subtraction step. 4 plus 12 is 16. And then when I have a number over a number, I can do that as division. So 32 divided by 16 is 2. Number 11, we have a word problem. It says the costs of tickets to a local amusement park are shown. Write and evaluate an expression to find the total cost for 5 adults and 8 children. So it says adults are 45, and I have 5 of them. So to find the total cost, I would multiply those. So I'd say 5 times 45. And then I also want to know how much it would be if we also have 8 $25 tickets, 8 children. So 8 times 25. So 5 times 45, to use the distributive property, which we've talked about, which is section 1-4, I can break that up into 5 times 40 plus 5, because remember on the quiz we're not going to use calculators. So we need to be able to do these things in our heads. So 5 times 40 and then plus 5 times 5. Alright, now we're going to use order of operations. So the first one I run into is 5 times 40. And that's just 5 times 4, which is 20, with an extra 0, so 200. 5 times 5 is the next one I run into, so that's 25. And then 8 times 25 is the next one I run into, and that's just 200. And I add them all up. 225 is 225, plus 200 is 425. And since it's a word problem, we want to make sure to include our units there of dollars, since it's asking for the total cost. Number 12, it says write an algebraic expression to represent the perimeter of the rectangle shown below. Then evaluate it to find the perimeter when W equals 8 centimeters. Well, remember we've done several of these in class, and to find the perimeter, it means add up all of the sides. And since it's a rectangle, the sides that are opposite are the same. So if you notice, you have 2 pairs of W and 4W minus 3. So one way you could write the expression would be to actually just go around and add them up as you go. So if I start at the top, I'd have 4W minus 3 plus W plus 4W minus 3 plus W. So that's one way to do it. And then I would go through and simplify. And I'd have a minus 3, and a minus 3 gives me minus 6. And I have 4W plus 1W is 5W, plus 4W is 9W, plus W is 10W. The other way that I could do it is to say that since I have two of these things that I circled here, I would just put them in parentheses being added together. 2 times W plus 4W minus 3. And then I can simplify the stuff in between. So W plus 4W makes 5W. And then if I use the distributive property, I would have 2 times 5W minus 2 times 3, or 10W minus 6. So either way, the expression I find is 10W minus 6. Then I go through and I'm going to evaluate if W is 8. So if W is 8, then I'm going to take my equation, or my expression, and substitute 8 in for W. So 10 times W is 8 minus 6. And then order of operations, I do 10 times 8 first, which is 80, minus 6. And 80 minus 6 is 74. And it said 8 centimeters. So my final units would be centimeters. And that matches answer C. Evaluate each expression, name the property used in each step. So we're moving on to section 1-3, which talks about properties of numbers. So we're going to use order of operations, and we're also going to name what's happening in each step. So by order of operations, I do what's inside the parentheses first. And the first thing inside the parentheses that I can do is exponents. So 2 to the third, which is 8. So I would say that this is 8 minus 8 plus 21. And that's going to be the substitution property, which says that if it's equal, you can put it in the expression as a replacement. And we said 2 to the third is equal to 8. The next one is inside the parentheses, I have 8 minus 8, which is 0. And that's going to be by the additive inverse property. And that says that if you add the opposite of a number onto it, it'll equal 0. And remember that when I say 8 minus 8, what it really means is 8 plus the opposite of 8, which is 8, plus negative 8, which is 0. And then the last step is 0 plus 21, which is 21, and that's the additive identity. And the additive identity just tells us that if I add 0 onto something, it just equals itself. Alright. Number 14. So the first thing I'm going to do is rewrite what 1 divided by 3 can look like. I'm going to write it as a fraction instead. So instead of having 1 division symbol 3, I'm going to write it as a fraction 1/3. And that again is substitution. If they are equivalent, I can put them in for each other. So 1 divided by 3 equals 1/3. The next thing I'm going to remember is that 3 as a fraction is actually 3 over 1. And then 3 over 1 times 1 over 3 is 1. And that's by the multiplicative inverse property. And that says that if you multiply something by its reciprocal or the inverse, which means the fraction flipped over, it equals 1. And the last one, 1 times 9 is 9. And that is the multiplicative identity property, which says that anything times 1 is itself. In number 15, I go inside the square brackets and I find parentheses again, so I need to do those first. So 3 times 1 is 3, and that's going to be the substitution property. Or excuse me, not the substitution, multiplicative identity property. The next step is I'm going to substitute 5 divided by 3. I'm going to write that as a fraction, 5 over 3. And that's the substitution property. It says that if they're equal, I can write them in for the other one, replace them. So 5 divided by 3 is equal to the fraction 5/3. And now I have reciprocals, 5 on top and 3 on the bottom in one, 3 on top and 5 on the bottom in the other. When I multiply reciprocals together, I get 1. So that's the multiplicative inverse property. Number 16, I'm going to change the order of things to make it go a little bit easier. When I see an 8, I'm hoping to find something that ends with a 2, so they'll make a nice even 10. So I'm going to put 18 plus 32 plus 35 plus 15. So 18 and 32 I want to do together. And 35 and 15 I want to do together. The reason I could reorder in the first step is because of the commutative property, which says that order does not matter for addition and multiplication. And then the reason that I can put parentheses around in the second step is the associative property, which says that grouping in addition and multiplication does not matter. So 18 plus 32 is 50. And 35 plus 15 is also 50. That's the substitution property, because 18 plus 32 equals 50. And 35 plus 15 equals 50. And then my last step, I'll put down here, 50 plus 50 is 100. And that's also the substitution property, because 50 plus 50 equals 100. So I can just substitute it in. All right, my next and last one is for number 17. I'm going to replace 0.25 with another equivalent way of saying that, which is the fraction 1/4. So I'm going to do 1/4 times 7 times 4, and that's by the substitution property, which says that 0.25 is the same thing as 1/4. Then I'm going to put the 1/4 and the 4 next to each other with the commutative property. And remember that 4 is the fraction 4 over 1. And that's the commutative property, which says order doesn't matter in addition or multiplication. These two are reciprocals, so when I multiply them together, I get 1. and that's by the multiplicative inverse property. And then my last step, over here I have 1 times 7, which is 7. And that's because of the multiplicative identity property. Anything times 1 is itself. All right, then we use the distributive property to write each expression, then evaluate. Distributive property means that if there's a number outside the parentheses, I can take that and multiply it by each one inside the parentheses. So to rewrite the first one, I would say 3 times 5. Keep the sign that was in between, which is plus. 3 times 2. And then evaluate. 3 times 5 is 15. 3 times 2 is 6. And 15 plus 6 is 21. In number 19, we have the number behind, which does the same thing, but if you're more comfortable with it in front, you can always just switch it to the front because the commutative property says order doesn't matter when you're multiplying. So we'd have 12 times 9. The sign in between is minus. So you'd have 12 times 9 minus 12 times 6. And 12 times 9 is the same thing as 12 times 10 minus 1, in case you don't know that offhand. So we're going to use the distributive property again. 12 times 6, I know offhand, is 72. Then we finish and do the distributive property for this. 12 times 10 is just 120. 12 times 1 is 12. So 120 minus 12 is 108. And then 108 minus 72, I can do by hand. 6, and then 10 minus 7 is 3. So 36. Again, the whole usefulness of the distributive property is to be able to do mental math quickly. And we're not going to use calculators on the quiz on Friday. All right, and the last one, distribute the 8 through. So I have 8 times 7 minus 8 times 4. 8 times 7 is 56, minus 8 times 4 is 32. So I would have 4 and 2, 24. Says use the distributive property to rewrite each expression and then simplify. So now we're going to do the same thing that we were just doing with numbers with variables as well. So the 4 gets multiplied by both things. So I have 4 times x plus 4 times 3. I don't need to put the times symbol in when I'm finishing up my writing, so I can just write 4 next to x, and then 4 times 3 is 12. Since I don't have any like terms, this has an x and this doesn't. There's no more parentheses, it's simplified. Number 22, I have the number behind. It doesn't matter if you're more comfortable with it, you can rewrite it in front. So 6 times 7 minus, and then 2y times 7. 6 times 7 is 42. Then 2y times 7, I multiply the numbers. 2 times 7 is 14y. Again, one has a variable, one doesn't, and I don't have any parentheses left, so that is simplified. And the last one on the page, Negative 5, I want to make sure when I write that I put parentheses around it to keep the negative straight. So I'm going to have negative 5 times 3m minus negative 5 times 2. Well, negative 5 times 3 is negative 15m, and then minus negative 5 times 2 is negative 10. And when I subtract the negative, it's the same thing as adding a positive. So negative 15m plus 10. All right, down to the last two questions. DVD sales. A video store chain has 3 locations. Use the information in the table below to write and evaluate an expression to estimate the total number of DVDs sold over a 4-day period. So what I could do is take the number at location 1 and multiply it by 4. Take the number at location 2 and multiply it by 4. And then take the number at location 3 and multiply it by 4. But what that would look like then is 145 times 4 plus 211 times 4 plus 184 times 4. And since every one of these has 4, I can now use the distributive property and say, well, it could have been written this way then, where I add all of these separately and then multiply by 4. So inside the parentheses, I have 145 plus 211. So I get 6, 5, 356 plus 184. And if I add those together, I get 10, 6 is 14, 540. And then $540, if it makes it easier, if you're not quite sure what it is, I can break up into 540. Because remember, we're not using calculators. So 4 times 500 plus 4 times 40. 4 times 500 is just 20, because that's 4 times 5, and then you stick 2 zeros at the end. And then 4 times 40 is 4 times 4 is 16, with a 0 at the end. So my final answer is 2,160 DVDs. Last problem, rewrite the expression using the distributive property. So again, if you want, you can rewrite it with the negative 2 in front. It doesn't matter. But basically, you need to multiply the negative 2 by each thing. So I have 8 times negative 2, and I put it in parentheses just because there's a negative. I want to keep them straight. And then minus 3p times negative 2. Well, 8 times negative 2 is negative 16. Oops, sorry. And then minus 3 times negative 2 is negative 6. And when I subtract a negative, it's the same thing as adding a positive. So you can change both those. So negative 16 plus 6p. So I look at my options, and that's option H.